Yeah, hi there. Continuing with our time series forecasting. So we have covered the bottom up and the top down approach that we can follow in the forecast. Now there are some of the rules that we need to know in the time series forecasting. One is the granularity rule. So granularity rule says that the more aggregate our forecasts are, the more accurate our predictions would be. So because if the data is aggregated, it will have lesser noise and lesser variance. Let's say if you want to make any prediction of a new show that has started, and one way is you who you want to predict at each area level, and the other approach is you want to predict at the city level. Now if you go at the granular, very granular, like at the city level, then it may happen that one particular area of a city is not watching that new TV show much, whereas the other area is watching the TV show much. So you will see a lot of variation in terms of the data that you collect based on the different areas of the city. But whereas if you aggregate it, or if you go up to the next level of the city level, then your prediction will be more balanced with less variation, or with the less variance and less noise. So it's better to have data aggregated at aggregated level, so that will have a better uh, accuracy if you want to predict. The next is the frequencies. Now, how often we are updating our forecast? It's also very important. Are we? Is it like we are making a forecast now for, let's say, for next 1 year, and then we are done? No, it will not help. So what happens basically in the real world? We keep on getting data on a frequent basis. So ideally, we would want to make the use of this new data that is being available to us, and we want to incorporate that data in our model. So in this way, what we are doing is we are getting more new data, and if we are incorporating it into our model, then the chances of our model for the future prediction going correct will increase. So it's better to have a, a frequency which is like it could be a monthly frequency, to update the forecasting. Another thing is that we should not update our model too frequently also, because otherwise it will have a downside effect. Because let's say if you are updating our model based on, let's say on the daily basis, based on something that is happening now, it may generate noise, because what is happening now, it could be not something that is relevant from the future perspective. So you want to give a sufficient breathing space between making changes in your model. So the frequency should not be very less, and it should not be very high. So it should be reasonable enough, so that you know that okay, it could be like once in a month, or on a monthly basis, that you update your model, and accordingly you make the future predictions. So the next is the horizon. So the forecast that you are making, if it is for a very long horizon, let's say you are forecasting for a 1 year, then the chances of you going accurate will be less, because the forecast for the shorter horizon, because that is the shorter the horizon of the forecast, the lower will be the degree of uncertainty, and data do not change very much in the shorter of time. So the data that you have in hand uh, will help you more in giving a prediction in the near future rather than in a very, very long term. Yeah, even though you are incorporating new data in the previous step that we discussed on the frequency, but still, if you have a slightly shorter duration for prediction, that will be a bit more accurate compared to a very long duration. So continuing further, so next topic is what are the different components of a time series model. So basically, once we have a time series data, so what are the different components it contains? So first is the level. A level of a time series is the baseline around which the average of the time series and the future goes as a horizontal line. So this is the baseline of a time series. This gives the baseline to which we add different other components. So if you hear the term like level or the level index of a time series data, it means people are referring to the mean of the series. So just like we have, for example, if we have given a data, then there is a mean of it. So that's what we call as a level. Next is a trend. So trend can be upwards or downwards. Okay, so over a period of time, you can see, let's say the stock price of a stock has gone up or has gone down. Yeah. So the trend captures over a long term whether the series moves up or lower. For example, in the Sensex graph, we can clearly observe for a given stock over a period of time with the time whether the price of the stock is increasing or it has decreased. So while referring to the term in the time series data, it means that the data has a long-term trajectory, which can either be trending in the positive or the negative direction. So when we say positive direction, it means we say that over a period of time, the price of a stock has gone up, or over a period of time, if the price has gone down, we say that it is going in the negative direction. Or another example could be a trend of a company in the increase in sales, in the sales of the product. For example, if you see, let's say take stock price of one company, and let's say at the start of the year it was 80, and by the end of a year it came down somewhere around 35. So the overall trend is negative, or it's going down. In between, you can see some fluctuation, but the overall trend, the overall observation that you get from this is that it has gone down. Now, next important component of a time series data is the seasonality. So, seasonality is a repeatable pattern in the data which repeats themselves after a given period, and the period is also fixed. So, it is a pattern in the time series data that repeats itself after a given period of time. So, if there are regular and predictable fluctuations in the time series data and that are correlated with the calendar, that is, it could be a weekly fluctuation, quarterly fluctuation, or a monthly or a seasonal fluctuation, then the series has a seasonality component. So, and it is also domain specific. For example, we can see the sales of an AC selling company going up during reaching peak during the summer season while it goes down during the winter season. So here the change in the weather, summer to winter. So seas that is a seasonal effect it is having on the sales of air conditioners of the company. Now, a seasonal pattern exists when a series is influenced by seasonal factors. So one is what we saw as the, let's say, summer winter season. Other could be some festive season. So uh, let's say a particular festive season comes, and the sales of a particular product starts going up. So that is also a seasonality effect. Now, next is the cycle. So repeating periods that are not related to the calendar. So we see some repeated patterns, but those patterns they don't have a fixed duration, you know, and also these repeatability is not related with the calendar. That is any specific season. So that is the actually cycle. So it could be a business cycle. For example, you might notice a particular industry is doing well over a period of time, then there is a downward trends, and that industry um, doesn't do well over next few years, and then again it peaks up. So that is called as a business cycle, which has economic downturns and later upturns. So the key difference is the interval between the cycle is not fixed, but it can be predicted that okay, we see a change in the business cycle after every, let's say, 5 years and 6 years. So another thing is it has a longer duration in a cycle compared to the seasonality effect. So the key difference, so often people get confused between what is a cycle and what is a seasonality effect. So they are really quite different. So if you see the fluctuations are not of fixed period, then they are cyclic. And if the period is unchanging and associated with some aspect of the calendar, then the pattern is seasonal. So if there is a pattern which is related to a particular calendar, let's say, or a particular season, for example, sales of some product going up during the winter season compared to during the summer season, or vice versa. So that is a seasonal effect. That is, every year you would see that kind of pattern. So that is the seasonality. So on an average, the average length of cycle is longer than the average length of a seasonal pattern. So cycles have a longer period uh, compared to the seasonality, and the magnitude of cycle, it also tends to be more variable than the magnitude of seasonality patterns. So that's the key difference between a cyclic effect and the seasonality. So the next component of a time series data is the noise. So all the time series data, we have some sort of noise or some sort of randomness in the data points that are not correlated with any of the other components like trends. So so noise is unsystematic and it's a short term. It is completely random, which is present in the data, and we cannot use this component for forecasting in the future because it is completely random. We cannot say anything about it. So obviously, we would want to filter out the noise in our model before making the future prediction. So another thing to note that it is not necessary that all the time series data will include all of these components all the time. So it may possible that a time series data has a noise, a level, but it may not have any seasonal, cyclic, or the trend patterns at all. So it depends upon the data. Based on that, it may have different components that we need to analyze while doing the time series analysis.